find the workspace depth for storage batteries in a solar photovoltaic system without a specific voltage, you can follow a process that involves estimating the workspace depth based on the battery type's nominal voltage. The process involves several steps. Firstly, calculate the amp-hour capacity of the battery. To do this, determine the battery type, for example, whether it is a lead-acid or lithium-ion battery. Then check the battery specifications for its amp-hour capacity. Secondly, estimate the energy consumption. Determine the peak power consumption of the loads that will be powered by the storage battery and estimate the average daily energy consumption in kilowatt-hours. Thirdly, determine the battery discharge depth. Discharge depth refers to the percentage of the battery's capacity that can be used without damaging it. A typical discharge depth for lead-acid batteries is 50 to 80%, while lithium-ion batteries can handle deeper discharge depths such as 90 to 100%. Fourthly, calculate the workspace depth. Workspace depth is the usable energy storage capacity of the battery. You can calculate it using the formula workspace depth in kilowatt-hours equals amp-hour capacity in amp-hours times discharge depth as a percentage times voltage in volts divided by 1000. Note that the voltage of the storage battery is not given, so it cannot be directly calculated. However, the workspace depth can still be estimated by assuming a nominal voltage for the battery type. For example, if it is a lead-acid battery, use 12 volts, and if it is a lithium-ion battery, use 48 volts. To illustrate this, let's assume a battery system with a 100 amp-hour lead-acid battery, a discharge depth of 50%, and a nominal voltage of 12 volts. The calculation would look like this: workspace depth in kilowatt-hours equals 100 amp-hours times 50% times 12 volts divided by 1000, which equals 0.6 kilowatt-hours. Therefore, the estimated workspace depth for the 100 amp-hour lead-acid battery is 0.6 kilowatt-hours. Next, consider a lithium-ion battery system rated at 100 amp-hours, a 90% discharge depth, and a nominal voltage of 48 volts. The calculation would be workspace depth in kilowatt-hours equals 100 amp-hours times 90% times 48 volts divided by 1000, which equals 4.32 kilowatt-hours. So, the estimated workspace depth for the 100 amp-hour lithium-ion battery is 4.32 kilowatt-hours. Factors influencing battery workspace include temperature, which affects battery performance. High temperatures can reduce battery life, while low temperatures can reduce capacity. Also, the age of the battery and the number of charge and discharge cycles impact the battery's ability to store energy. Over time, batteries degrade, reducing their capacity and workspace depth. The state of charge influences workspace depth, as a fully charged battery will provide the maximum workspace depth, while a partially charged battery will provide less. Regular maintenance, such as cleaning terminals and ensuring proper ventilation, can help extend battery life and maintain workspace depth. When selecting a battery for a solar photovoltaic system, it's essential to consider factors such as the battery's capacity, voltage, discharge depth, and lifespan. Also, it's crucial to choose a battery that is compatible with the solar inverter and charge controller. Proper sizing of the battery bank is crucial to meeting the energy needs of the loads and ensuring reliable operation of the solar photovoltaic system. An undersized battery bank may not provide enough energy, while an oversized battery bank may be unnecessarily expensive. By following these steps and considering the relevant factors, one can effectively estimate the workspace depth for storage batteries in a solar photovoltaic system even without the specific voltage.